Have you ever stopped to think about how you can start a car with just the turn of a key? Or, get cash out of an ATM with just a few button presses? Well, the secret behind all of that is this incredibly powerful concept called abstraction. And honestly, it's the hidden force that makes our super complex world feel surprisingly simple.
All right, let's start with what feels like a magic trick. It's one you've probably seen 1,000 times, maybe without even noticing it. It's a trick that happens pretty much every single time you use any piece of technology.
I mean, really think about that for a second. You push one button, and this huge, complicated system of pistons and gears and electronics just roars to life. How in the world does that one simple, tiny action control all of that underlying chaos? And it's not just in your car. It's the ATM, right? You stick a card in, punch in a pin, and bam, cash comes out. You don't need to know a single thing about encryption or how it's talking to the bank's servers. All that crazy complexity is totally hidden from you. This magic, it's literally everywhere.
So what do we call this magic trick?
Well, it's not really magic, of course. It's actually a very deliberate and, frankly, brilliant design principle.
And there it is, abstraction. At its heart, it's the art of hiding complexity. You're given a simple set of controls, and all the complicated, messy machinery is just tucked away, completely out of sight and out of mind.
This quote just nails it, doesn't it? The steering wheel, the pedals, that's your simple interface. The engine, the gears, that's all the hidden complexity. You can be an amazing driver without being a mechanic. That is the power of abstraction.
Your TV remote is a perfect little case study. On the surface, what you see are just simple buttons: power, volume, channels. But underneath that plastic is a whole world of internal circuits, infrared signals, and microchip logic doing all the heavy lifting. We only ever have to deal with the simple part.
Okay, so we get what it is. But so what? Why is this idea so incredibly important? Especially when we're talking about building the software that runs, well, everything.
Just try to imagine for a minute a world without abstraction. To write a single piece of software, you'd have to manage every tiny detail of the hardware. It'd be like trying to build a skyscraper, but first you have to personally forge every single nail and mix the concrete by hand. Software would just be this tangled, unmanageable mess. Impossible.
But with abstraction, boom, the whole game changes. Code becomes clean, organized. All that overwhelming complexity gets neatly tucked away, which lets developers focus on what actually matters. Solving real problems and building cool things.
So here's the bottom line. Abstraction isn't just some nice-to-have concept. It is the fundamental strategy we use to manage and control the absolutely immense complexity of modern technology. It's how we build skyscrapers instead of getting stuck just making bricks.
Okay, so we get the what and the why, but how do programmers actually pull this off in their code? Let's take a quick look at the tools of the trade.
In the programming world, especially in what's called object-oriented programming, it really boils down to these two key tools: abstract classes and interfaces. Let's break down what each one does.
So first up, we have the abstract class. The best way to think about this is like a blueprint. You can't live in the blueprint itself, but it provides a detailed template and sets out all the rules for any house that gets built from it. So let's walk through a quick example. First, we create our blueprint, an abstract class called animal. Then, inside that blueprint, we set a rule. Every animal must have a way to make a sound. We don't say what the sound is, just that the ability has to be there. Finally, we can create a specific class, like dog, that uses the animal blueprint and provides its own unique version of that sound, a bark.
And then we have the interface. Now, if an abstract class is a blueprint, an interface is more like a strict, legally binding contract. It is nothing but a list of rules that a class absolutely must follow, no exceptions. It tells you what something has to do, but gives zero details about how to do it.
For example, you could have a vehicle interface that has just one rule: all vehicles must be able to start. It's then up to a car class or a motorcycle class to sign that contract, so to speak, and provide their own specific logic for what starting actually means for them.
Okay, we've covered the tools. So where can we actually see this powerful idea at work in the software we use every single day? Well, the short answer is pretty much everywhere.
Seriously, think about it. From payment systems like Stripe that handle billions of dollars, to game engines like Unity that build entire virtual worlds, abstraction is what makes it all work. Each one of these things hides an insane amount of complexity behind a simple, usable front.
This allows developers to build amazing things on top of them without having to reinvent the wheel every single time. It's the only way these massive systems are even possible.
All right, let's pull all these ideas together. We've seen what abstraction is, why it's so critical, and the tools used to build it. But what's the one single, transformative idea at the very heart of it all?
This is it. This is the whole point. Abstraction lets us separate what a thing does from how it does it. It lets us think on a much higher level. We get to focus on driving the car, not on the physics of internal combustion. And that simple shift in focus is what makes all technological progress possible.
But of course, it's not a magic wand. Abstraction is a powerful tool, and that means it requires balance. It's amazing for cutting down complexity and making things more secure, but there are always trade-offs. If you hide too much, it can be a real nightmare to figure out what's wrong when something breaks deep down inside that hidden layer. The real art is finding that perfect balance, hiding what's not important, but keeping what's essential accessible. That's what great engineering is all about.
So, the next time you use any piece of technology, just take a second to appreciate all those hidden layers of abstraction that are making it all possible. And maybe ask yourself, what other magic tricks are out there just waiting to be understood? Thanks for tuning in.